Hi guys, it's a one and only Miss favorite teacher. Now in this session we're gonna be basically dealing with physical science. Now we are still on the topic of electricity. So now we're gonna be concentrating on resistors in series. Now on the previous lesson I did explain, but I didn't go further because I wanted you to get an understanding of how basically we work with different symbols that we have in electricity. Now on this session I'm just gonna go into the greater details of how to basically work with electricity if you're in grade 10 or as a grade 10 learner. Now here let's say this represents our R1. So if it's R1, it means to say it's the first resistor. If that is gonna be R2, that is gonna be what? That is gonna be the second resistor. Now one thing that is very important with this is that these are resistors in series, and one thing that you must understand is that resistors or resistance is measured in ohms, right? So if I'm having the first resistor there, and which is represented by R1, and the second resistor which is represented by R2, if I were to calculate the total resistance, which we're gonna say is R total, so R total, it will be me now saying R1 plus R2. It means to say you're gonna add the first resistor together with the second resistor. Now one thing that you must understand is that with regards to resistors in series, you must understand that the current is the same through each resistor. So you must understand that the current is the same through each resistor. That's one thing that you must know. And then secondly, you must understand that voltage is split. Voltage is split up, right, across resistors. Now this you must know because it's going to help you to be able to understand electricity much better, right? And then the voltage is directly proportional to the resistance. You must also know that the voltage is directly proportional to the resistance. The voltage is directly proportional to the resistance in the series combination resistance in the series combination, right? The voltage is directly proportional to the resistance in the series combination, right? Then you're gonna say full stop. And then you must also know that most voltage will be across the largest resistance, right? So most voltage will be, so the most voltage will be across the largest resistance, resistance. Now if you can know this, then you're gonna go far with regards to electricity, right? Then you must also know that the voltage divider, right? So that is voltage divider. By having voltage divider, because the voltage it divides, then the current is the same through each resistor. And then lastly, you must understand that yeah, I think that is it with regards to the series combination. Now on the previous session I did elaborate more with regards to what, with regards to the symbols that you must know with regards to electricity, right? Now let's look at the resistors in parallel. Now if you can understand this, then resistors in parallel. So with regards to this one, as having resistors in parallel, I'm gonna make also an example that you can be familiar with, so that you don't stress yourself. That is one example that I can portray there. To be able to assist you. So as you can see here, we're having resistors in parallel. Just like that. So this is key, because you're gonna find it in an exam. So you must know how do you work with the resistors in parallel. You must know also how do you work with the resistors in series. So let's also say this one will be represented by R1 right here. So let's say R1 the first resistor, then you're gonna also have R2, which is the second resistor. Now this one, it was resistors in series, but this one is resistors in parallel. Now with regards to resistors in parallel, what's going to happen? We know that our formula for resistors in parallel is gonna be what? It's gonna be 1 over R total, which is equals to 1 over R1, 1 over R1, which plus 1 over R2. So if I were to calculate the total resistance, that is the formula that I'm gonna be using right there. Now with that being said, these are some of the key points that you must understand with regards to resistors in parallel, right? So the first one is that the current is split up through resistors. So the current is split up through resistors. That's the first one. And then the second point, you must know that the current is inversely proportional. The current is inversely proportional. The current is inversely proportional to the resistance. The current is inversely proportional to the resistance, right? This means that the smaller resistance, this means that the smaller the resistance, the more current going through it. The more current going through it. So if the resistor is small resistance, there's a lot of current that is going through that, right? Then our third point right here, it will be a voltage is the same across each resistor. Voltage is the same across each resistor. Voltage is the same across each resistor in the parallel combination, comma, in the what? In the parallel combination. The parallel combination. In the parallel combination, the voltage is the same across each resistor in the parallel combination, right? And then we're gonna also have what? The current divider, because the current it divides. We're gonna have the current divider because the current it divides, right? So that's how basically it is. Now if you can understand this, then you are good to go, right? So these are just the basics that basically you must understand with regards to that. So with regards to this, these are some of the definition that you must know. So when we speak about current, we are speaking about the rate of flow of charge, right? Is the rate of flow of a charge. So that is what? That is current, right? And then its unit, the unit for current is measured in what? Current is measured in capital letter A, which you call it amperes. Current is measured in ampere, right? So this means that it's how much charge passes every second. So those are some of the things that you must understand. And then previously I did elaborate to say what? To say current, if you remember, I say current is measured, don't forget, with an ammeter. Current is measured with an ammeter, which is connected in series. So I did elaborate this, right? And then when you now speak about potential difference, I did elaborate on this. So when you speak about potential difference, so we are speaking about the energy transferred. We're speaking about the energy transferred. The energy transferred per unit electric charge. Transferred per unit electric charge. And don't forget that charge is measured in coulomb, right? And then the unit for potential difference is that it is measured in V, capital letter V, which is volts. Potential difference is measured in volts. And then don't forget that also we're gonna have a formula that says V, it's equals to W/Q. Right? So with regards to potential difference it's how much energy each coulomb it's how much energy each coulomb how much energy each coulomb of charge transfers between 2 points. Transfers between 2 points. So that's what we mean by that. And don't forget that a potential difference is measured in parallel using a voltmeter. It's a device that we use to measure potential difference, which is the voltmeter. So that's what we mean by that, right? So you must understand this, guys, because this is going to basically assist you with regards to now mastering electricity, so that you don't get confused, right? Now there's something that I wanna show you. So we're gonna have a circuit. We are having a circuit here. Let me just do this. Now this is an example. So that is the example that we are having. So we are having a circuit that has the following resistors here. So that is our parallel combination right there. Take note of how the circuit is being drawn. Then we're gonna have a battery. On this side. So here we are having a battery. Just like that. So this is gonna be our R1, which is our first resistor R1, which is 5 ohms. So here we're having 5 ohms. So R2 we're having 8 ohms here. And then here we're having R3, which is also 8 ohms. And then here it's R4, which is going to be 6 ohms. And then here we're having our battery, which is 60 volts. So we can label this as R1 that will be R2, R3 the third resistor, as well as R4 the fourth resistor. Now here we're gonna calculate. I'm just trying to bring questions that are gonna help you to simplify this. So let's calculate the total resistance. Number one, we're gonna calculate the total resistance. Total resistance. So as we're calculating the total resistance, remember we're gonna use we're gonna first calculate the parallel combination of the circuit, right? So that's gonna be 1 over R parallel, which we say RP, or some textbooks they write it like 1 over R parallel like that. So it's still one and the same thing, it doesn't matter, right? It's gonna be equals to 1 over the parallel combination, it's R2 plus 1 over R3, which is the third resistor there. Now what we are going to do from here, we're gonna write 1 over R parallel to get the parallel combination, which is gonna be 1 over our second resistor there, R2 is 8, plus 1 over our third resistor there is 8, right? Then our 1 over R parallel is equals to, now you take your calculator, you basically calculate, right? So it's 1 over 8 plus 1 over 8, that gives you 1 over 4. 1 over 4. Remember that since this is 1 over 4, we are looking for R parallel. So R parallel, it's equals to, swap them, which is gonna be 4 over 1. Therefore R parallel is gonna be equals to 4. But remember, for us, we are looking for what? We are looking for the total resistance, which is gonna be R total, which is gonna be R total. It will be now us saying R1, which is the first resistor, plus R parallel, which is the R parallel combination, which will include the second resistor as well as the third ohm resistor right here, right? Plus R4, which is gonna be the fourth resistor. Now as we are continuing, the total resistance here, it will be what? It will be R total, it's equals to R1, that will be what? That will be 5 ohms, plus, and then the R parallel combination is gonna be 4 ohms, we got 4 ohms, plus, and then the fourth resistor there is 6 ohms, 6 ohms. Then therefore R total is equals to, then you add, that should be 15. So it's 5 plus 4 plus 6. That should be what? That should be 15 ohms. So 15 ohms, it represents what? It represents your total resistance that you are basically having. So that's how basically we solve this, guys. It's your favorite maths and science teacher. Stay tuned for more.